Hello friends, welcome back to my channel. This is Aaheli Bhattacharya, a B.Sc Statistics and Data Science student, and today we are going to make frequency distributions come alive. Don't worry, no scary math monsters here, just some simple concepts explained in a fun way. So, let's get started. First up, class mark. What is a class mark? Class mark is simply the mid value of a class interval. Imagine you are stuck between two numbers, say 10 and 20. What's the middle value of it? It is 15. That's your class mark. So, by definition, it is mid value of what? Class interval. So, what is the formula for it? Formula is class mark is equal to lower class limit plus upper class limit whole divided by 2. Okay? Next comes class width or size. Okay? This is just the difference between the upper and lower class limit. For example, if the if the class interval is 20 to 30, the class width is 10. Okay, easy, right? Next comes the interesting one actually. Next is frequency density. Yes, frequency density. What is that? Frequency density of a class is its frequency per unit width. So what is the formula for it? Formula for it is class frequency divided by class width. This helps us when classes have unequal widths, especially while drawing histograms, okay? Helps us in classes having unequal widths while drawing histograms. Okay, next comes uses of frequency density. Yes, uses of frequency density. So, why do we even care about frequency density? Here are the main uses. Let's say point by point, okay? First is it gives us the concentration of frequency in a class. Concentration of frequency in a class. Next is it is useful when classes have unequal widths. When classes have unequal widths. Okay. Third point is helps in drawing histograms for any unequal classes. Helps in drawing histograms for unequal classes. Point number 4 is makes comparisons fair when intervals are not the same. Makes comparison fair when intervals are not same. And point number 5 is it gives a more accurate picture of data distribution. A more accurate picture of data distribution. Basically, it's like adjusting pizza slices so everyone gets a fair share. Alright, coming to our next topic, which is cumulative frequency. What is it? Cumulative frequency, or like CF as we denote it, this is like keeping a running total of frequencies. A running total of frequencies. For example, if the first class has 5 and the second has 8, then the cumulative frequency will be 5 plus 8, which is 13, and it will continue so on. Okay. What are the uses of cumulative frequency? First up is it helps us to locate median, quartiles, deciles, and percentiles. We will know each term later in this chapter, okay? Next up is it is essential for drawing ogives or cumulative frequency polygons. For drawing ogives, which is also known as cumulative frequency polygon. Okay? Next our topic is stem and leaf diagram. Okay? Now let's look at something a little different but very useful. Yes, so what is the definition for it? A stem and a leaf diagram is a way of displaying quantitative data where each number is split into a stem, okay, which is the first part, and a leaf, which is the last digit. Okay, this shows how the data is distributed while keeping all the original values. You will understand it better with example. Okay, suppose we have the data 12, 14, 15, 21, 23, 25, 31, 33, and 36. Now let's make the table of stem and leaf. Stem is the first part, as you have seen. So what is the first part here? 1. And leaf is the last digit. See? So what is the last digit for ones? Is 2, 4, 5. Alright? So we'll write it like this, 2, 4, 5. Not basically using the commas. 2, 4, 5. Okay? And next, which is 2. 2 is the stem. And what are the leaves of it? 1, 3, and 5. So 1, 3, 5. And the next is 3, which is the stem. And what are the leaves? 1, 3, 6. 1, 3, 6. Okay? Here, the stem 1, here, this one, means the tens. We know that. And leaves 2, 4, 5, which means basically 12, 14, and 15. As I've already discussed, right? So what are the uses of it basically? The uses, let me point it down. First is it preserves the original data. Preserves the original data. Next is it shows distribution shape clearly. Shows distribution shape clearly. Third is quick and simple to construct. Quick and simple to construct. Point number 4 is useful for small to medium sized data. For small and medium sized data. Alright, it's like making a mini data garden, right? Where numbers grow on stems and leaves. Beautiful, right? Yeah. Now coming to the next part, which is diagrammatic representation. Let's start with the visual things, all right? But for just a disclaimer that in the next video, I'll show you how to plot the graphs. And here in this lecture, I have not put any diagrams of the graphs, okay? I'll put it on my next video. So yeah, let's start it. First comes histogram. What is an histogram? A histogram is the most common diagram of a grouped frequency distribution. Grouped frequency distribution. Okay, it consists of adjoining rectangles drawn on a baseline with areas proportional to class frequency. This is also important. Areas proportional to class frequencies. When all classes have equal width, this is also important. When all classes have equal width, rectangle heights are proportional to frequency. Proportional to frequency. When classes are unequal, then rectangle heights are proportional to frequency density. To frequency density. This is actually important. Okay, now coming to the uses of histogram. What are the uses? Pointed down. Shows visual representation of data. Visual representation of data. Next is helps compare groups at one glance. Compare groups at one glance. Number three is tops of rectangles can give an idea of the frequency curve. Tops of rectangles can give an idea of the frequency curve. Right? Point number four is it is used to find the mode graphically. Mode graphically. And the point number five is it makes the entire distribution easy to understand. Easy to understand. Okay, so basically histograms are data which is Instagrammable. Very sweetly said, right? Now coming to the next part of diagrammatic representation, which is frequency polygon. So what is a frequency polygon? If histograms are too boxy for your taste, we will try frequency polygon. The definition will be a frequency polygon is obtained by joining the midpoints, joining the midpoints of the tops of histogram rectangles, of histogram rectangles with straight lines, with straight lines. So yes, what are the uses? Uses will be first, it gives an approximate idea of the frequency curve shape, gives an approximate idea of the frequency curve shape. Number two is it is useful for simple frequency distributions of a discrete variable. Useful for simple frequency distribution for discrete variable. Alright. Number three is easier for comparison than histogram sometimes. Easier than histograms. Alright. Now the next part, or basically the last part of diagrammatic representation, is the ogive. Ogive, which is also known as cumulative frequency polygon. And so finally, the ogive, also called, as I said, cumulative frequency polygon, it is a graphical representation of cumulative frequency. Okay, graphical representation of cumulative frequency. Okay, there are two types actually. One is less than ogive, and other is more than ogive. For less than ogive, cumulative frequency is plotted against upper class boundaries. This is something to remember, okay? Less than is plotted through upper class boundaries. and more than, as you can understand, the cumulative frequency will be plotted against lower class boundary. Lower class boundary. All right. Now coming to the uses. Uses of Ogive graph. First is it helps to find median, quartiles, deciles, and percentiles. Okay. Number two is it shows cumulative distribution clearly. Cumulative distribution clearly. Okay. Number three, it is great for comparing how data accumulates step by step. Comparing how data accumulates step by step. Okay. So yeah, today we covered Classmark. Let's go back. What are the things we covered? Today we covered Classmark. Yeah, here it is Classmark. Then class width, frequency density, uses of frequency density, cumulative frequency, and again its uses. These are the uses. Then stem and leaf diagram. Then we have the diagrammatic representation for we have three parts, which is histogram and its uses, frequency polygon and its uses, and then the last, which is ogive and its uses. Okay. So yeah, that's a lot, but trust me, once you get this, you have unlocked a big chunk of statistics basics. In the next video, I'll teach you how to plot graphs step by step. So yeah, stay tuned. If you found this helpful, don't forget to like, share, and subscribe because even statistics need some distribution of love, right? So yeah, this is Aaheli Bhattacharya signing off. See you in the next one. Bye.